Hi everybody, and welcome to your video lesson on the unit circle. So first, let's have a formal definition. A unit circle is a circle which is centered at the origin with a radius of 1. With a radius of 1. So let's see what it looks like. So here is my graph. And here is my circle. And I have, this is my radius, right, from the center of my circle to the edge. The radius equals 1. So that is what a unit circle is. It is often used in trigonometry. So here is this circle. In this case, I have a theta of pi over 4. That's in radians, obviously, right? Pi over 4. Or if you prefer to think of it in degrees, you could think of it as 45 degrees. That's what this angle measure is right here, pi over 4 or 45 degrees. Now, what I'm going to do is I'm going to draw a couple of lines here for us to consider. I have this straight downward line, this perpendicular line, and then I have this line right here. And I want to know a little bit about this triangle that I just drew. You will notice that this length right here is not a radius, this red horizontal line. It's not a radius because a radius would go all the way to the edge of the circle. And this does not go that far. It just goes that far, right? Same with this line right here, although it takes up all of this space, this line is going to be shorter than what my radius is. And I know that, I didn't draw this perfectly, so you might not be willing to like bet your life on this, but I'm telling you that it's not as long as the radius. In fact, I know something about this particular triangle right here. Since I know that this is a 45, 45, 90 triangle, right? Here's my right angle, and these two sides are 45, 45. They have to be in a 1-to-1 ratio. So they're going to be the same length, x and x. And now perhaps you're feeling a little bit better. You can see that this line doesn't go all the way to the end of the circle. So you know that this horizontal line is not 1, which is my radius. And you know that this has to be the same length as this, right? Because those two sides are going to be the same length. So this also has to be smaller than my radius of 1. So let's see if we can't figure out exactly what the lengths of our sides are. How are we going to do that? Well, I'm going to do this by using the Pythagorean theorem. A squared plus b squared equals c squared. X squared plus x squared equals 1 squared. So that's going to be 2x squared is going to equal 1 because 1 squared is 1. I will divide both sides by 2. So I get x equals, x squared equals 1/2. So x squared is the same thing as 0.5. So x is going to equal the square root of 0.5, which, if I do my handy dandy calculator, 0.5 raised to the 0.5 will give me about 0.707. So this side length is about 0.707, and this side length is about 0.707. Okay, are you with me so far? I certainly hope so. So now let's look at this drawing again. Hold on, I'll draw it out for you one more time. So here's our thingamajig, and here's our circle, and here's our angle, and here are our side lengths. So we know that this is a 45, 45, 90 triangle, right? This is 45. This is 45. And so we know that it is also going to be in a 1 to 1 to radical 2. Right? Don't we also know that about a 45, 45, 90 triangle? Yes, we do. And we know that this is the same thing as 1. X radical 2 is the same thing as 1 because this is a unit circle, so our radius has to equal 1. Let me just write this over here so it looks all fancy-dancy. That's our formula. X root 2 has to equal 1. All right, let's solve for x. So I'm going to divide by root 2. And now I could put that in my calculator and I would get some wonky kind of answer, but I don't want to do that. I instead want to rationalize this denominator, which means simply we'll multiply it by root 2 over root 2 so that the root 2's disappear in the denominator. So I wind up with root 2 over 2. You with me? Root 2 over 2. That is the length, or that is the value of x. Root 2 over 2 times root 2 would give me 1. Let's just prove that to ourselves. Root 2 over 2, that's our x value, times root 2. Does that give me 1? Well, root 2 times root 2 would be root 4 over 2. Does that equal 1? Well, the square root of 4 is 2, so 2 over 2 does indeed equal 1. So instead of writing about 0.707 here, like we did on the previous page, I could also write that this is root 2 over 2, and this is root 2 over 2. Either way is correct. Usually in trig, we're going to see this because they want a most precise answer, which is kind of silly because there's so much rounding in trigonometry. But anyway, that is what they would do. All right, let's take a look at this same triangle again. So here we have the same triangle. We have this side is root 2 over 2. We have this side is root 2 over 2. And this side here is 1 because it is our unit circle. Are you with me? And root 2 over 2 is the same thing as about 0.707. 0.707. Okay? All right. So far, so good. All right. So let's take a look at that angle right there, which we know is pi over 4 radians, which is the same thing as 45 degrees. Let's take a look at this theta and let's figure out what different things are. For instance, what is sine of theta? Well, remember the formula for sine is opposite over hypotenuse. So in this case, it's going to be root 2 over 2, that's my opposite side, over my hypotenuse, which is 1. And that's going to reduce to simply root 2 over 2. Okay? How about cosine of theta? Well, cosine is going to be adjacent over hypotenuse. And your adjacent is root 2 over 2 divided by your hypotenuse, which is 1. So again, this is root 2 over 2. And what about tangent of theta? Well, that's opposite over adjacent, which in this case is going to be root 2 over 2 over root 2 over 2, which reduces just to 1. So I know that these numbers look weird, but I want you to see how everything is kind of tying together. Our sign still means the same thing, opposite over hypotenuse, and we can fill it in with these numbers, even though they're weird numbers, root 2 over 2. All right, so let's pull out our handy dandy calculator. The first thing that I want you to do is to look to see if you are in radians or degrees, because it matters. I am going to go to degrees because I know that that's what most of you are doing secretly. So let's just go ahead and do that. And let's calculate the sine of 45 degrees. So I'm going to do sine 45, and that equals, look at that, 0.707, right? That is exactly what we said this side was, root 2 over 2, 0.707. See how it's all working out? Cosine, same thing. Cosine of 45 degrees, 0.707. Tangent of 45 degrees is 1. And this is unusual, right? To get an actual, like, normal looking integer as our answer here. Yeah, but that's what we got. So that is basically what a unit circle is. Here's something that I'm going to show you, though. When we, here, let me go back to our previous picture. I will go with this picture right here. This is our first picture. Remember we were talking about how long this side was? Well, this horizontal length right here is always your cosine. So your cosine was 0.707 and the length of that side is 0.707. And this vertical length right here is always your sine. And our sine was 0.707 in this case. And that is always true. When you're looking at a unit circle, you can look at the vertical line and get a sense of what the value is of sine, and you can look at the horizontal line to get a sense of cosine. And just because that's a little funky, I think we should write it down in our notes. So vertical triangle edge equals sine value. And our horizontal triangle edge equals our cosine value. Which kind of makes you wonder, what's our tangent value? You are going to have to wait for another video for that. But it is exciting. Okay, that is it on the beginning of unit circles.